Okay, good morning everyone. Welcome to Starfest. Thank you for coming. If you haven't got a schedule, you can pick one up at the door later on, and that will tell you all the times of the talks today, and we've got quite a few good ones today. We've also put in bigger breaks this year, so you've got a lot more time to go and see the exhibits, buy some stuff from the traders, and spend your good money. I'm going to hand you over to your host for the morning, who is Jerry Workman. He's going to introduce some of the talks and take you through the talks this morning. So please welcome Jerry Workman to introduce the talkers.
Thank you. Thank you very much. I hope you can hear me. I'm not going to do an impression of Tom Jones because my singing isn't very good. What I'm going to do is I'm going to be introducing the speakers this morning, and we've got three very good ones. We'll start off with Robin Scagell is going to talk about comets. Then Ian Ridbarth's going to talk about the moon. And then finally, the Stuart Clark, who's Vice President of this society, he's going to talk about the Caesarium of God, which is basically about Isaac Newton and God. So that's quite an interesting talk as well. We're going to start with Robin. Now, I've known Robin for quite a few years now, and he's a prolific author, writer, and broadcaster on astronomy. And I've got a number of his books. Probably the best book of his I've got is a book on astronomy with binoculars. Very practical guide, very ideal, I suppose, for London observers like myself. He also frequently gives talks to societies and at events like this, for instance. Also, he is the Vice President of the SPA and has been for many, many years. I'm sure he won't tell me how long that is, but quite a few years. Also, in 2011, he won the Eric Zucker Award. It's an award from the FAS, the Federation of Astronomical Societies, and that is for an outstanding contribution to the public understanding of astronomy. That's a big national award. And also, because he is a journalist and works with the media, sometimes he's asked to give very short notice discussions about astronomy, like at the drop of a hat. So he has to have these things at his fingertips. What are you going to do today? You're going to talk about comets, you're going to talk about what they are, how to observe them, and also, of course, maybe next year, if we're lucky, we're going to see two very good comets in 2013, one in round about springtime and one towards the end of the year. So without further ado, Robin Scagell on comets. Robin.
Thanks very much, Jerry. After that introduction, I can hardly wait to hear what I have to say. Welcome to you all. I can't think of any better ways to spend a Saturday in Braintree. So I hope you enjoy it. This is a talk, as you can see, on comets, and this is a popular level talk. And I'm aware that some of you are probably quite advanced. I've seen quite a few comets, but that doesn't matter. I'm still going to give a popular level talk, but I will skim over some of the things which I talk about, because you probably know them already. And if you didn't, you say, oh, I knew that. I always find that even with amateur astronomers who have been to many meetings and all that sort of thing, there's always one or two things that maybe they needed a bit of revision on, shall we say. Okay, this is a picture of Comet Hale-Bopp, as I'm sure many of you know. I say many of you because it wasn't until this comet came along that, for many people, they really knew what a comet was. And I'll talk about the fact that in days gone by there seemed to be comets galore, as it says here, and then it wasn't until Comet Hale-Bopp came along that the majority of people actually got to see a comet in any way, shape or form. And I say now, most of you will have seen Comet Hale-Bopp, but remember that it appeared in 1997, and that means that anybody under the age of about 20 or 22 or so won't remember this comet. It's quite a long time ago now. And as Joe was saying, maybe the popular conception of comets will be improved over the next year as we have possibly two comets coming along. And I'll be looking later on at the circumstances of those comets' appearances and talking about what we might be able to see. So, comets. Well, I often have to say, it's amazing, when as soon as you start a laptop, you always want to update something. No matter if you update it that morning, it always finds something new. Okay, comets. As I say, popular talk. So one of the things I tell everybody is that the difference between a comet and a meteor, which I'm sure you appreciate, there is a big difference, but a lot of people don't appreciate what it is. And a comet, as you know from having seen Comet Hale-Bopp, if you saw it, is it can stay in the sky, if you're lucky, for weeks on end, looking more or less the same, as if it's whizzing through the sky, but actually staying in one place more or less from night to night, just moving slowly from place to place. A meteor, however, is over in a second or so, it's just a flash in the sky. And the two are related, but this isn't really a talk about that. I will come on to that very briefly later on. So that's the difference between a comet and a meteor, and what a comet looks like up in the sky. And comets can still arouse a certain amount of fear among the population. It's surprising in this day and age how people can be surprised by the appearance of a comet. There is a story. There was a story about a year ago that, in fact, we might be we might actually see a lot more comets, and perhaps they could even become dangerous to us. But again, I'll come on to that a bit later. So, what is a comet? Well, and there's another picture of Comet Hale-Bopp, that time over Stonehenge. Comets have been appearing in the sky for thousands of years, and of course, as I say, some of them gave rise to a lot of fear. But in fact, their origin dates back to the very birth of the solar system. And the solar system, as I'm sure you all know, was born in such a thing as the Orion Nebula, not the Orion Nebula itself, but one that was around in this neighbourhood, the sun was born from maybe 4.5 billion years ago. So it's long since gone, that nebula. But the Orion Nebula is an example of the birthplace of stars. And in the middle of that, you will get lots of material forming just by chance under the influence of gravity, and then they will condense, and here's such a formation, a solar system in the course of formation. You can just about see perhaps the glimmer of a star in the middle of that. That's a huge thing, much larger than our own solar system, but it shows you a knot of material that is condensed and maybe one day will form a solar system in its own right. And the early solar system was just a mass of material of all sorts of shapes and sizes. And from that maelstrom of activity, you see a couple of comets appearing there, and the protoplanet, and lots of bodies all whirling around. Out of that was born the solar system we know today, more or less, with a very obvious distinction between the rocky planets close towards into the centre of the solar system, and then the more lightweight planets farther out. And in between the two, there is this bunch of material, which we call the minor planets or asteroids, which in effect represents the leftovers that couldn't get together to form a rocky planet. And so you have the heavier material in towards the centre of the solar system and the lighter material towards the outside. How it all got there is another matter, but we won't go into that now. So that's the sort of snowball fashion, with things actually gathering together momentum and creating those planets of different sizes. Also, as well as the more gassy planets, Jupiter, of course, is mostly hydrogen, so is Saturn. And further out, you've got other things in there as well. And in fact, people call these the gas giants. They used to call them the gas giants. I prefer to call them the giant planets, because really Uranus and Neptune are not so much gas giants as water worlds, really. There's very little free gas in Uranus. It's mostly water inside. And so I don't think gas giants is an appropriate term these days for all four planets. But Jupiter and Saturn are undoubtedly mostly gas. But as well as the gas that's in those giant planets, we have a lot of ice as well. And this is the sort of thing that you get in the outer solar system. This is Saturn's moon Hyperion, and it's maybe a few hundred miles across, I forget how many, but out in the outer solar system there is an awful lot of ice. A lot of it is comprises the moons of the giant planets or the outer planets, and there are something like over 60 moons of Jupiter and Saturn alone, most of which look something like that. They're mostly ice. So you get the picture, lots of ice around in the outer solar system. It's so cold that carbon dioxide ice is quite common, but a lot of it is actually ordinary, straightforward water ice that we know and love on Earth. So it's very common. Now, the planets go around the Sun in roughly circular orbits. And as you also know, the time that Mercury takes to go around the Sun is a mere 88 days, and the further you go out from the Sun, the quicker, the slower things go. So the Earth takes a year, Jupiter takes 12 years, Saturn nearly 30, and Neptune 169. So where do comets fit into this? Well, you can see a typical orbit of a comet, and they fit in nowhere in particular. When we see them, they're close to the Sun, but most of their time is spent way out in the outer solar system. And this is a bit of a clue to where they come from. They do seem to come in from the outer solar system, where, as I've said, it's mostly ice. And we assume that there is a huge reservoir of comets out there, which we now call the Oort cloud. This Oort cloud could extend, there's a picture, which is obviously an artist's impression, because you can never see the Oort cloud as it is. The actual individual objects that are dotted here are so tiny in the vast scale of things that you could never actually see them until you got really close to each one of them. And it could extend something like a quarter of the way to the nearest star, the Oort cloud that extends around our Sun. And it contains possibly billions of comets, and as I said, they're mostly ice. Whether there's always been an Oort cloud is not clear, because scientists believe that in fact the icy bodies probably formed closer to the Sun than we see them now, and by various slingshot procedures actually have got thrown further out. And now there's a reason we know the Oort cloud has been there for billions of years, and most of these comets actually must have remained most of their time that far out. And I'll come on to that in a second. But we are just assuming that this is what it looks like. Incidentally, it was an Estonian astronomer called Ernst Öpik who first postulated the existence of this body of comets around the Sun. And you might have heard the name Öpik before. Of course, his grandson is Lembit Öpik, who was the well-known comedian. I've got it in for Lembit Öpik ever since. He once appeared at a light pollution conference saying, oh yes, we must do all we can to cut out light pollution, all these streetlights are a terrible thing. And then as soon as one of his constituents, when he had constituents as an MP in Montgomeryshire, said, oh, we can't, the lights have gone out on our street and we can't put our key in the lock anymore, he immediately said, this is taking us back to the Dark Ages, so two-faced. So, each of these bodies is made of ice, and that's one I'm sure you're familiar with. That's the nucleus of Halley's Comet. And it's something like 10 or 15 miles across, only a tiny thing in comparison with the size of a planet, and yet that body creates all the huge effect that we see of a comet. And despite the fact that I've said that there are billions of them, they only make up a mass in the whole solar system of about 5 times the mass of the Earth. So not a major component of the mass of the solar system. Now, a chunk of ice that size would soon melt if it came very close to the Sun. This is not in any doubt. And Halley's Comet, as you know, and comets that we see, they only spend a short time close to the Sun because they have these long looping orbits, which means that they spend a very short time close to the Sun and a very much longer time of their lifetimes a long way from the Sun, in effect not being warmed by the Sun to any great extent at all. Now, if every comet came as close to the Sun, if every one of those comets in the Oort cloud came close to the sun, and bearing in mind that the sun is billions of years old, and therefore you imagine that if they were in those orbits, they would have been, even if a comet has a lifetime of, takes sort of 100,000 years to go around the sun, it would have been in towards the sun hundreds and hundreds and hundreds of times, and therefore inevitably it would have melted by now. So we know that since comets are coming in at quite a rate every year that we've never seen before, and they can't have been coming in over a period of billions of years, just going round and round like the planets do, that they can only be coming in very rarely. And in fact, the ones we see are just a small fraction of the population. Otherwise, there wouldn't be any there left. They would have, if they'd been in those orbits over the period of the lifetime of the solar system, they would have all have melted by now. So that's how we know that there is an Oort cloud. And what causes them to suddenly come in? It could well be that the effect of passing stars way out in the outer solar system is enough to suddenly make an individual body, maybe, as I say, a quarter of the way between us and the nearby star, suddenly decide that it will come in and then go around the sun. Equally, some of those bodies could be deflected out of the solar system. And some of them might be given such a nudge that they appear to be coming from outside the solar system, but in fact haven't. And that's something, again, I will mention in a minute when I show you what sort of orbits they have. Incidentally, one of the consequences of this rain of comets into the inner solar system over billions of years is the fact that we have water on Earth. When I was not all that much younger, it was said that the water on the Earth, which of course we have, we rely on all that sort of thing, was due to outgassing from the early Earth, you know, the volcanoes and so on, spewed out water. And actually you think, well, if it's that hot inside the Earth, how come there's so much water there? But now the thinking is that some, if not all, of the water on Earth actually came from comets. And so, although people say we may be wiped out by a comet hitting the Earth, we quite likely owe our entire existence to comets in the first place. So that's something to be grateful for. Now, the story of a comet. Comets are discovered, as I said, in the outer solar system usually, or at least when they're some distance from the sun, hopefully. And these days they are mostly picked up by sky surveys, or when the smaller ones, when they actually get quite close to the sun. At this stage it's probably quite distant. That was a picture of the recovery of Halley's Comet, and people knew exactly where to look when it was well beyond the orbit of Jupiter. But quite a lot are discovered. Last year there were about 50 comets discovered that we weren't aware of, discovered by sky surveys or by visual means. People, well, mostly actually by sky surveys. They can be discovered by amateurs, but this is quite rare these days. And what tends to happen is that you see, these sky cameras tend to see bodies which move very slowly. As you see, that doesn't look particularly comet-like. In fact, I'll let you into a secret. This isn't a comet. This is a body that was discovered, which is not actually a comet, which is in the outer solar system, but it was the best picture I could find to illustrate the point. And you can see here a trail, and there's the times, just a few minutes separating each photograph, maybe for 3/4 an hour or so. And in the course of an exposure of maybe a minute or so, a closer body into the solar system, such as a minor planet asteroid, does tend to trail across the image. And there it is there, and there it is, and there it's moved on, and then it's out of the frame. Whereas a body in the outer solar system moves much more slowly. And that's how you know it's a long way out. As I say, it moves much more slowly. And so that's the discovery. Over a matter of a few days almost, it's possible to work out a rough orbit, which they do by assuming that it's actually got a parabolic orbit coming in from the outer solar system. If it were one which was having a much more circular orbit, they would need more observations, but that's the first assumption. And then after a matter of just a few days, it's possible to work out roughly what a comet will be doing and whether it will be coming in close to the sun. Most don't. Most actually stay fairly well out from the sun. They never come close to about the orbits of Mars or Jupiter or something like that. But no, by and large, the orbit of comet is anything but circular like those of the planets. There's the similar photograph of the comet Ison, which we'll be seeing next year, hopefully, no guarantees. Planets, as they go around in circles. Some comets go around in long ellipses. Something like Halley's Comet will go in an ellipse, something like that, with the sun at one, not at the centre of the orbit, but towards one edge. And most comets that we know of actually come in these parabolas, where, as you can see, the inner solar system is a tiny area like that. And eventually, somewhere way below the stage is where it would have started out. There we go. That would be way out in the Oort cloud. Then it comes in, starts to speed up, and spends a very short space of time in towards the sun, and then it slows down and it goes out again. Whereas these comets that are in elliptical orbits are known as periodic comets. They are the ones that we know have an established period, and they come around maybe just every few years, or more likely in tens of years. And the periodic comets are ones with periods, and that is returns to the sun, to the solar vicinity of less than 200 years. But the majority of comets have periods of much more than 200 years. So we'd spot it as a tiny little blob out in the outer solar system, or usually as a small object. And then as it gets closer, it starts to develop this coma or haze around it, which is some of the gas being melted off the body, gas and dust being melted off the body and evaporating in the heat of the sun. And as it gets closer still, you see that it starts to develop a certain asymmetry, and this is a typical appearance of a comet that is relatively bright, and most of them are just little haze around them. But rather than having a tail as such, it's just a sort of irregular, or rather asymmetric appearance around the centre there. I should say that the actual nucleus of this body is absolutely tiny. I mean, far tinier than the spot of the laser pointer there. If you consider that that is maybe tens of thousands of miles across, the actual body just a few miles across is really minute inside that area there. And then, of course, it comes in closer to the sun, and it starts to develop two tails, if we are lucky, if it's a really large body. You can't actually see the two tails, a bit too much light here, but the gas tail, the gas that's given off, forms a sort of bluer coloured tail as it fluoresces in the light of the sun. And the dust that's released from this body, which it gathered probably at the very start of the solar system, that is given off, that is released from the nucleus, and it tends to go into orbit around the sun, so that's why it tends to be a curved shape, because it's actually starting to orbit the sun. And incidentally, it is the dust from the tails of comets that give rise to meteors in the upper atmosphere. These are the things that have spread out. You can see that the tail is quite narrow there, but it spreads out as it gets away from the comet, and it keeps on spreading, and eventually it spreads out over a far greater width than the actual orbit of the comet, which is why we see these meteors in the sky, which appear to come from no particular direction. They're bodies that were released from comets maybe a million years ago, whatever, and they're just in orbits which are nothing to do anymore with the original orbit of the comet. Getting in a bit closer, these, if we're lucky, a really large and volatile comet nucleus that is maybe coming in for the first time, or has only been around the sun for a few times, can start to produce an extreme amount of gas and dust. And these are the ones we look forward to, the ones that come in close to the sun and produce a large volume of gas and dust. This was one called Comet Hyakutake, which appeared the year before Comet Hale-Bopp in 1996, and it was nothing like as spectacular as Hale-Bopp. But the comet's tail can be hundreds of thousands of miles long. In fact, in some cases, it can extend as long as an astronomical unit, that is the distance between the Earth and the Sun, something like 100 million miles. And obviously the body itself is absolutely minute on that scale. Halley's Comet is a good example of a periodic comet, and that was back in 1985-86, and here it was close to perihelion when it was at its closest. Not a particularly spectacular object, and this was photographed from the southern hemisphere where it was at its brightest. And you can see there, you can get the impression that, well, you know how bright the Milky Way is roughly, and you can see that the comet itself was not very much brighter than the Milky Way as a whole. I did go down to the southern hemisphere to see it in 1986, and it was certainly not something you would spot in the sky unless you happen to know the sky fairly well. It was just a tiny little speck, really, and its appearance had been much better on previous occasions, when, of course, it was quite spectacular. The last times it appeared were 1910 and 1986, and it gave rise to lots of exciting events were attributed to the appearance of Halley's Comet, such as the Battle of Hastings, which appeared when it appeared in 1066 by chance. And as we know, if something appears in the sky, a portent is expected. You know, it's something that a population will say, well, there must be something. People still do this. If people say, people are still very happy to attribute strange events to astronomical happenings, and there was a solar eclipse, and there was an earthquake the next day. It must have been caused by the solar eclipse. No, this is just us putting two together and making 22. So it's not necessarily any link at all. So that was a fairly long periodical comet. Here's a very short one. This is a very much enlarged photograph compared with the reality. It certainly wasn't on the same scale as the other one. Encke's Comet, which goes around the Sun every 3.3 years, in the same sort of orbit, more or less, as an asteroid. And in fact, you can hardly tell the difference between some comets and asteroids. And occasionally, asteroids are discovered to have a bit of a haze around them, and you realise that in fact they are more or less, they're probably extinct comets that now no longer give off any gas or dust. And it's a bit like those snowballs that you make by rolling, starting with a tiny snowball and then rolling it, and then it picks up lots of stones and dust and so on. And then eventually, once you've left it for a few days, you know it shrinks down and it starts to change colour, doesn't it? Because all the dust and the stones and the pebbles that you've rolled into it all accumulate on the surface as it shrinks and shrinks until it's quite small and it's almost black at that point. Whereas the snow around it is white, and so you know that it's not that it's somehow attracted lots of dust, it's the dust that has just melted down, that is accumulated on the surface as it's melted down. So that's what happens with the case of a comet, and eventually the dust actually clogs up all the pores, as it were, and it's no longer able to melt. It's just it just gives off a very tiny amount of gas compared with what it did when it was young. And so that's the difference between a periodic comet that's been around lots of times and got all clogged up with dust. Now, let's look at a few comets. As I said earlier, back in the 19th century there seemed to be comets all the time. And the great comet of 1858 was seen over Paris. There are lovely pictures of it appearing in the over the Notre Dame and that sort of thing. Donati's Comet it's called. That's a picture of it over in Cambridge, United States. Lovely sight. That's the star Arcturus, by the way. Now, of course, this appeared, and the comets in the 19th century appeared when light pollution was very much less. I won't say it was non-existent, because even in the 19th century people were remarking that you could see the glow of light over a town due to gaslight. We forget that gaslight started as early as 1840, and most towns by the middle of the 19th century had gas lighting, and so there was light pollution even in those days. But as you'll see from this next picture, comet of 1882, seen from Streatham, if it appeared today, that would be much less visible. You might just see the head of it, but not the tail there. And so that's one reason why comets seem to be so plentiful in the 19th century. And when I was a kid, in the 60s, 70s, whatever, well, okay, 50s, I was rather disappointed by this because no comets ever seemed to be seen in our days. There had been one back in 1948, which nobody ever saw. That was before. There was one in 65 called Ikeya, which we never saw from this country. There was another one called Aaron Roland, also around the same time, which I don't think I saw. It was sorry, that was 57. It was not well visible. Though if you knew where to look, you could see it. But I didn't know where to look. However, things changed back in 1970 when Comet Bennett appeared, and that really looked something like that. I've got to admit, this isn't the picture of Comet Bennett. I couldn't find one. I did see it. I did try and take a picture, but I couldn't take a decent picture in those days, only by propping my camera up on something. I didn't even have a tripod when it appeared, and my pictures weren't very good. But it appeared very much like that. This was Comet Hale-Bopp again. And it appeared in the early morning sky almost like a dagger pointing down towards the ground. And I heard stories that people coming off night shift, people like nurses and so on, saw this object in the sky, which in those days, astronomical news was very hard to come by, which is why a lot of us had to join societies and so on. And they were actually concerned. What is going on? Is this a rip in the heavens? You know, they were quite frightened by it. Anyway, we must digress. A lot of you may have heard of Comet Kohoutek in 1973, which was reputed to be a monster comet that would really make very spectacular. And leaflets were produced like this, telling people what they should do and which religious organisation they should join. But it never happened. It was an absolute flop. Then Halley's Comet 1986. Okay, we were getting some comets. Hyakutake 1996. There you are, you can just about see it. There's the Pleiades. See, it's not particularly spectacular in the sky. Then, of course, we had Hale-Bopp, and there you can see the two tails. And so that is more or less where we were until 2007, when for a day or two only, we saw Comet McNaught. Now remember this picture, I'll show it again in a minute or two, because it's quite interesting to compare what we're going to have with Comet McNaught. The comets tend to be named after their discoverers, incidentally, where there is an actual human discoverer rather than a survey. Now, Rob McNaught down in Australia actually does run a survey, but rather cannily, being a Scot, he attaches his own name to every comet. So he is by far the most prolific discoverer of comets ever. He has now got 70, I think it's 62 comets with his name on only, or 73 co-discoveries. So there are lots of Comet McNaughts, and people say, well, you can't just refer to Comet McNaught or Comet Pan-STARRS, you've got to give the actual description. And this was 2006, I can't remember, RP1 I think it was, something like that. But that was the one that everyone thinks of as Comet McNaught. And that photograph was taken on January 10th, 2007. And now, why didn't we tell everybody to look out for it? Well, remember what I said about Comet Kohoutek, absolute flop. Comets are very unpredictable, and this is why we're so concerned about what we say about the comets that are coming up next year. Will they be really spectacular? Will they be an absolute flop? And we don't know at this stage. Very difficult to say. And that's why no fuss was made about Comet McNaught, because the worst thing is, you work it out. Which is better to say, there may be a good comet in the sky tonight if you look very close to the horizon, and if it's really crystal clear, which it was on that occasion, and looked out there, and then people go and say, and they see it, and they say, wow. And then if it happens to be a bit cloudy or a bit hazy, they don't see a thing. And they say, oh, look out there, you people don't know what you're talking about. And, well, you know, where are you? So you can't cry wolf too many times, really. down in the southern hemisphere, Comet McNaught was very much better visible after perihelion. It moved down into the southern hemisphere. Of course, this is one of the problems. You can have an absolutely wonderful comet which happens to be apparently below the sun as we see it, and therefore the tail tends to spread out in that direction away from the sun. And from the southern hemisphere it's absolutely fantastic, and we see nothing at all, or we see very little. That picture I showed you just there, that was taken before it reached perihelion. It's closer to the sun, when it was north of the sun, and when it was south of the sun, it appeared like that. Incidentally, these multiple tails are caused by dust having been released on previous occasions, and each clump of dust tends to go in its orbit around the sun, and that's why you get this apparent multiple tail appearance. So that's a picture actually taken by Robin McNaught of his comet. It didn't appear quite as spectacular as that to the naked eye. Long exposure photographs do tend to bring out far more of the tail than you can actually see. Comet Holmes was one that we saw in 2007 as well, and it was a comet way out beyond the orbit of Jupiter, but somehow it suddenly produced a pocket of gas, and it became millions of times, or a million times, brighter than we'd ever expected it to be. And over a period of a matter of a month or so, it expanded, and it was visible with the naked eye. That's a bit of an exaggeration, but you could certainly see the comet from a suburban or an area like this without any trouble in Perseus there. And that was quite an interesting sight to see. I better progress very quickly because I'm running out of time. Comet Schlüsselmacher, we were all delighted with a name like that when it actually broke up. We didn't have to say it anymore. But that broke up, as you can see there, when it was quite close to the sun on one occasion, and that's a photograph from the Hubble Space Telescope. This is the fate that befalls lots of comets, that they can break up or they can clog up, and that's why they're so unpredictable. Malcolm Hartley, back in 1986, here's a picture. Actually, that's a photograph of Halley's comet, but he also discovered, just a couple of weeks before I took that photograph, a comet called Comet Hartley, which appeared in 2010. And here's a photograph. It was one that came very close to the Earth. And here's a sequence of it moving over 1 hour and 40 minutes, which I took from my back garden. And just a series of exposures added together. And you can see the comet there moving through the stars. They don't usually move as quickly as that, I've got to say. But that was one that, although it was a fairly close comet, as you can see, no tail to speak of. So when we look for comets, they can be spectacular, they can be only binocular objects, or they can have no tail at all, even if they're close to the sun and to the Earth. On that occasion, that comet was photographed by the Deep Impact probe, which went very close to it, and that shows the nucleus of it. And you can see gas actually being, not only gas, but particles of dust, which will become eventually meteors, being given off by the nucleus. Fantastic photograph of that. As I said, people tend to get their names associated with comets. This is a picture of Thomas Bott, taken a couple of years ago, and he discovered his comet, which bears his name, when he was looking at an object in, I think he was looking for the Messier object M30, and he found it, and he thought, this doesn't look quite right what it's supposed to be like, and he realised that he'd actually been looking at a new object, which was the comet. At the same time, Alan Hale, also in America, spotted exactly the same thing. But it so happened that Alan Hale was closer to a telephone at the time, and he could actually phone up the news of the discovery to the International Astronomical Union in Cambridge, Massachusetts. So his name came first. Otherwise, if Thomas Bott had been closer to a telephone, he could have got there first, and it would have been Bott Hale. Now, visual discoveries are still made, and in fact in 2010, two Japanese there were two visual comet discoveries by amateur astronomers, one of which was made by a chap called Ikea, who discovered that comet back in 1965 that I referred to just now. So it is still possible, but by and large, the discoveries tend to be made by survey. I will skip over this business about destruction by comets, and I shall also just allude to this question of comets plunging into the sun. A lot of comets that are discovered, like that one there, are discovered on these photographs by the SOHO satellite. And various amateur astronomers and people who want to make a name for themselves, if you like, will study the SOHO images that come out each day and look for these comets. And something like 200 comets are discovered each year on the SOHO images from space. When the satellite first went up there, or rather the spacecraft first went up, back in it's about 20 years old now, anyone help me? When was SOHO launched? 1997, it says here. There were 67 comets discovered on its photographs, and now there are something like 200, and that is what has prompted someone to suggest that maybe the number of these very small but objects going very close to the sun has increased. But I suspect it's simply because people weren't really looking for them back in 1997, and now they are far more prominent. Incidentally, the explosion off the sun there was not caused, although it looks as if the comet, this is a loop as you know, it looks as if it caused the explosion, but that's probably not the case. So, are we going to see a new great comet? Well, here's some of the great comets that have occurred. Some of these are apparently related, and there is a theory that back in millions of years ago there was a really giant comet that broke up and spawned a lot of these, what I call great comets. And as you can see, we've actually had a fair share of great comets during the 20th century and into the 21st century. And so it's not really true that comets were more visible in former times, except that they were perhaps, in the absence of light pollution, they were more obvious. I really must hurry now. If you hear about a comet, what's the best way to find out about it? Go to the BAA or the SBA websites and go to the Comet section, and there you will find a list, rather difficult because they're both of the same sites are done by the same guy, and you will find, if you go down far enough, what comets are around at the moment, and you will get a table of positions like this, which is not the easiest of things to interpret, but if it's a really bright comet, on the SBA website we usually give a finder chart to show you where it is. You can plug the same information, usually all this data here can be put into, well not that, yes it is there, can be put into your sky mapping computer program, and these orbital elements define the orbit of the comet, and you put it in and get your own predictions as well. And that's how you put it into SkyMap, for example. You've got to get the right figures in the right places, but then you can predict the orbits of comets. Right, let's move on to what we expect to see in 2013. This is the one that Errol's talking about. This is the predicted track of Comet Ison, and this shows its positions actually in the morning. You'll see this is the track coming in November. It comes in this way towards the sun, and the magnitudes are completely guesswork. It says magnitude 1.2 there, in other words visible with the naked eye, but we have no idea. It could be as bright as that, it could be fainter. I suspect it will be fainter. But nevertheless, it comes in a fairly dark sky and then goes around the sun on November the 28th, and then it emerges from the sun, from past the sun. If we're lucky, it goes very close to the sun, within 2 million kilometres, and if it still survives, then it may be visible in the evening sky. And now, this is the evening sky appearance for November 2013. In fact, this is actually the position on December the 1st. There's the sun, there's its position on the 6th of December. Now, remember that orientation, with the sun down there, to the same scale. Here's the position of Comet McNaught, which I showed you the picture of. And you can see there's the sun, and there's Comet McNaught. Actually, sun 7 degrees below the horizon, and Comet McNaught on that occasion was less than a degree above the horizon. In fact, they're about 1.5 degrees above the horizon. And that was the circumstance under which that picture was taken, with a magnitude of -2.5. In other words, as bright as Jupiter ever gets. And that's what it looked like on those occasions. On that occasion. So if we're lucky, Comet Ison may be visible like that, but it rapidly fades as it gets further from the sun, and it may not be as spectacular as we would like. A better chance is, I think, from Comet Pan-STARRS, which will appear in March. And there again is the sun, and here's its positions It's at perihelion on, I think it's the 9th of March, and then it moves away, but from the sun, but in the evening sky as far as we're concerned. And again, these magnitudes are complete guesses. Magnitude minus 0.5, 1.8, 3.8. But nevertheless, it's moving into a dark part of the sky. And here's a close-up of that. Notice that it actually moves quite close to the Andromeda Galaxy, which is just about there. That's 4th of April. When the comet may be around mag 4, 5, or even brighter, who knows. So, comet Pan-STARRS, that's the view on the 6th of March, 16th of March, when it will be something like that, with the sun quite well below the horizon and in the dark sky. So I have greater hopes from comet Pan-STARRS than from comet Ison as a comet to look for and possibly visible with the naked eye. Right, I've overrun my time. Let's just have a look at what we all hope we will see on some occasion. Comet Ikeseki 1966, as seen from Kick Peak, a lovely bright comet with a tail sweeping up halfway across the sky. Who knows, it could happen tomorrow, something may be spotted that's come in from the far side of the sun and nobody has been looking for and is just there by chance. It could happen next year, we could see a great comet, or it could be another 10, 20, who knows. Some of the younger people here today may actually be the only ones to see a really great comet in their lifetimes, but we may be lucky next year. Thanks very much.
Thank you very much, Robin, for entertaining, informative and sometimes quite amusing talk. Now I'm looking at the time, and the idea I think this time was to give people more time for break. So Robin's going to be around for a while, I know, and he'll probably be on the SBA stand for a while as well. So the best thing to do, if you've got any questions to ask him about the comets or about the SBA section or anything like that, it's best to speak to him during the break or later on. Now the next lecture is by Ian Ridpath. It's about the moon, and it starts sharp at 11 o'clock. So can you please be back for that? Thank you very much.